excuse me, as I've said, this unit method is useful for deriving rough estimates of total costs or benefits during the preliminary stage of the project. The total estimated cost or benefit is computed as the total number of units multiplied by the cost or benefit per unit. This is the formula. Okay, total estimated cost or benefit is equal to the total number of units times the cost or benefit per unit. For the demonstration on how to use this method, look at this example. Okay, so using the unit method in estimating a total cost. This example is taken from the book, the reference book by Blank and Tarkin. This is the problem. Justin, an ME with dynamic castings, has been asked to make a preliminary estimate of the total cost to manufacture 1,500 sections of high-pressure gas pipe using an advanced centrifugal casting method. Since plus minus 20% estimate is acceptable at this preliminary stage, a unit method estimate is sufficient. Use the following resource and unit cost factor estimates to help Justin. Okay, these are the resources that will be used in manufacturing 1,500 sections of high pressure gas pipe. And for materials, the number of units is 3,000 tons, and the benefit, the cost, unit cost factor is $45.9 per ton. Okay, and for the machinery and tooling, the number of units is 1,500 hours, and the unit cost factor is $120 per hour. For the direct labor, in plant, there are two here, the casting and treating direct labor cost. The number of units is 3,000 hours, and the unit cost factor is $35 per hour. For the finishing and shipping direct labor, the number of units is 1,200 hours, and the unit cost factor is $45 per hour. Now, for the indirect labor, the number of units is 400 hours, and the unit cost factor is $75 per hour. Now, for the solution, to find the estimate of the total cost, we simply add up the total cost per resource. Add up, this is total cost per resource. The total cost per resource is just the product of the resource, number of units, and its unit cost factor. Okay, and so we have this estimate of the total cost to manufacture 1,500 sections of gas pipe. Another example, using the unit method in estimating a total benefit or revenue. This example was taken from the reference book by Sullivan and others. This is the problem. A project manager is deliberating about the design of a commercial building project. He analyzes the potential revenue impacts of the following considerations. First, the first floor of the building has 15,000 gross square feet of floor area for retail space, and the second floor has the same area planned for office space. And based on discussions with the sales staff, he developed the following additional information. Letter A, the retail space should be designed for two different uses. 60% for restaurant operation with a utilization of 79% and a yearly rent of $23 per square foot, and 40% for retail clothing store with a utilization of 83% and a yearly rent of $18 per square foot. Now, for the restaurant operation, its unit benefit factor is this yearly rent, which is $23 per square foot, and its number of units in square feet is the product of the 79% utilization, the 60% space allocation, and 15,000 square feet of area of the first floor, floor area of the first floor. For the retail clothing store, its unit benefit factor is this yearly rent of $18 per square foot, and its number of units in square feet is the product of this 83% utilization and the 40% space allocation and the 15,000 square feet of floor area of the first floor. Okay, now for letter B, there is a high probability that all the office space on the second floor will be leased to one client, just one client, with a utilization of 89% and a yearly rent of $14 per square foot. Again, for the office space, the yearly rent of $14 per square foot is the unit benefit factor, and the number of units is the product of the utilization, 89% utilization, the floor area, the space allocation, which is 100% because there's only one client, and the floor area of the second floor, which is equal to 15,000 square feet. Okay, because only one client will occupy the whole of the second floor. Now, letter C, an estimated 20 parking spaces can be offered for rent at a rate of $22 per month per parking space on a long-term basis to two existing businesses that adjoin the property. For parking spaces, its unit benefit factor is this $22 per month per parking space, and its number of units are these 20 parking spaces. Okay, letter D. Also, one spot along the road frontage can be offered for rent at a rate of $65 per month per billboard to a firm who will put up a billboard without impairing the primary use of the property. Again, for this, the billboard, its unit benefit factor is $65 per month per billboard, and its number of units is just one because there's only one spot for one billboard. Okay, now using all the data and information gathered, estimate the total benefits or revenue that can be generated from the commercial building project. Okay, solution. So the total estimated total annual revenue is just equal to the sum of the annual rent revenues from the restaurant space, the clothing space, the office space, the parking spaces, and the billboard space. Okay, in formula form, okay, for each of the restaurant, clothing, and office spaces, this is the formula for computing the annual rent revenue. No? It is equal to the rent per year times the utilization times the space allocation times the total floor space. Okay, now for the parking spaces, its formula is the rent per month per parking space times 12 months to get the annual rent revenue, okay, times the number of parking spaces. For the billboard space, its formula is the rent per month per billboard spot times 12 months to convert this to an annual rent revenue times the number of billboard spaces, which is only 1, no, equal to 1. It's only 1. Okay, these are the figures or the values. For the restaurant, this is $23 times 79% utilization times 60% space allocation times the first floor area of 15,000 square feet. For the clothing space, is equal to the $18 per rent per year times the 83% utilization times the 40% space allocation and times the 15,000 square feet floor area of the first floor. For the parking spaces, for the office space, okay, it is equal to the $14 rent per year times the 89% utilization times the 100% space allocation, because only one client will occupy the whole of second floor, times the 15,000 square feet floor area of the second floor. For the parking space, you have here the rent per month per parking space of $22 times 12 to convert it to an annual rent times 20 parking spaces. For the billboard, you have here the $65 per month per spot, no, times 12 months to convert it to the annual rent revenue times 1, because there's only one spot for the billboard. And this is the estimated total revenue. Okay, the next method, called the index method. This method uses cost indexes in deriving the estimate of a total cost. This method can be used only in estimating a cost. Okay. Now, a cost index is a dimensionless number that indicates how the cost or the price of either a single item or a group of items has changed over time with respect to a base year. Examples of single items are equipment, machinery, labor, material, and utilities. Examples of group items are different consumer or producer products that are lumped together. Cost indexes are published by some government agencies like the Bureau of Statistics and the Department of Labor for free, and by some private organizations for a price. This method uses this following relation for estimating an unknown cost of an item. Okay, this is the relation, no? Unknown cost of an item at present time over the known cost of an item at maybe a similar item at previous time is equal to the ratio of the index of an item at present time and the index of an item or similar item at previous time. Okay, and to compute for the unknown cost of an item at present time, this is the formula. Okay, we simply transpose this denominator here to the other side. Okay, for the demonstration on how to use this method, look at this example. Using the index method in estimating the total cost. This example was taken from the reference book by Newnan and others. Okay, this is the problem. A production analyst is interested in estimating the annual labor and material costs at present for a new production facility. He was able to obtain the following labor and material costs data. Okay, for the labor costs, this labor cost index was at 124 10 years ago and is 188 today. And the annual labor costs for a similar facility were $575,500 10 years ago. For the material costs, the material cost index was at 544 3 years ago and is 715 today. And the annual material costs for a similar facility were $2,455,000 3 years ago. Using the obtained cost data, he computes the annual labor and material costs at present as follows. Okay, solution. Using this formula, the index method formula, in determining the estimated annual labor cost of the new production facility at present. So this is the formula, no? So estimated annual labor cost at present is equal to the annual labor cost 10 years ago. So known, no? This is known. And times the ratio of the labor cost index at present and over the labor cost index 10 years ago. Okay, plugging in here the given known values, no? So the annual labor cost 10 years ago is $575,500 times the ratio of the labor cost index at present to 10 years ago. So at present 188, 10 years ago 124. And this is the estimated annual labor cost of the new production facility at present. For the annual material cost, the same procedure, no? So estimated annual material cost at present is equal to this, no? The annual material cost 3 years ago times this ratio, material cost index at present over the material cost index 3 years ago. Plugging the given known values for this, and you have this estimated annual material cost of the new production facility at present. Okay, another method called the factor method. This method uses a cost factor in deriving the estimate of a total cost. A cost factor may be given as one overall cost factor or as separate cost factors for each individual cost components such as construction, maintenance, direct labor, direct materials, indirect cost elements, and others. If the cost factor is given as one overall cost factor, it is simply multiplied to the cost of the major delivered equipment or item in order to derive the estimate of the total cost. By the way, this method can be used only in estimating a cost. Okay, to continue, if the cost factor is given as separate cost factors, excuse me, these separate cost factors are added up and the sum is added by 1 to derive the overall cost factor. This overall cost factor is then multiplied to the cost of the major delivered equipment or item in order to derive the estimate of the total cost. Now, cost factors are derived by experienced analysts and experts in the industry and can be obtained from a number of sources in the industry, such as industry reference books, handbooks, technical journals, etc. Now, for the demonstration on how to use this method, look at this example. Okay, so example 1, using the factor method in estimating a total cost. This example was taken from the reference book by Blank and Tarkin, and this is the problem. An engineer with Valero Petroleum has learned that an expansion of the solid fluid process plant is expected to have a delivered equipment cost of $2.08 million. If the overall cost factor for this type of plant is 3.63, estimate the plant's total cost. Okay, solution. Estimated total cost of the solid fluid process plant is equal to, since the cost factor is given as an overall cost factor, which is 3.63, we simply multiply this to the delivered equipment cost of $2.08 million dollars, and you have this estimated total cost of the solid fluid process plant. Another example, using the factor method in estimating a total cost. This example is taken from the reference book by Blank and Tarkin. This is the problem. The delivered equipment cost for a small chemical process plant is expected to be $2 million. If the direct cost factor is 1.61 and the indirect cost factor is 0.25, determine the total plant cost. Okay, take note that the cost factors are given as separate cost factors, that is direct cost factor and indirect cost factor. So before we could compute for the estimated total cost of the chemical process plant, we need to add up the two given cost factors to get the overall cost factor. So add up plus 1 and you have this overall cost factor, and then this overall cost factor will simply be multiplied to the delivered equipment cost of $2 million, and you have this estimated total cost of the chemical process plant. Another example, using the factor method in estimating a total cost. This example again was taken from the reference book by Blank and Tarkin. This is the problem. A new container handling crane at the port of Singapore is expected to have a delivered equipment cost of $875,000. The cost factor for the installation of tracks, concrete, steel, noise abatement, supports, etc. is 0.49. The construction factor is 0.53 and the indirect cost factor is 0.21. Instructions. Determine the total cost if, letter A, all cost factors are applied to the cost of the delivered equipment, and letter B, determine the total cost if the indirect cost factor is applied to the total direct cost. Okay, solution. Notice that the cost factors are given as separate cost factors. Okay, so for letter A, to determine the total cost if all cost factors are applied to the cost of the delivered equipment, so first we compute the overall cost factor by adding up all the given cost factors and add 1 to get this overall cost factor 2.23, and then we simply multiply this to the delivered equipment cost of $875,000 to get the estimated total cost of the new crane. For letter B, determine the total cost if the indirect cost factor is applied to the total direct cost. Okay, total direct cost. So first, we have to determine the total direct cost. And how to determine that? Now first, we need to determine the overall direct cost factor, and this is composed, the overall direct cost factor is composed of the other two cost factor that are not indirect, that are not, so excluding 0.21, the indirect cost factor. Okay, so we add them up plus 1 and to get this overall direct cost factor. Okay, and multiply this to the delivered equipment cost to get the total direct cost. Okay, now to get the estimated, now the instruction is to apply the indirect cost factor to the total direct cost, meaning first we need to calculate the overall indirect cost factor. There's only one indirect cost factor, so add 1 to that and you have this excuse me, you have this overall indirect cost factor of 1.21. Okay, now to get the estimated total cost of the new crane, we simply multiply this overall indirect cost factor to the total direct cost. Okay, and so we have this estimated total cost of the new crane. Now if you'll notice, this is bigger than when we directly apply all the when we apply all the cost factors to the delivered equipment cost, and also as well as to the direct cost, total direct cost was separately computed. This has the largest or the biggest estimated total cost of the new crane. Okay, another method called the power sizing method. This method uses a power sizing exponent, also referred to as cost capacity factor, in deriving the estimate of a total cost. This method can be used only in estimating a cost. Okay, and this method recognizes the concept that cost varies as some power of the change in size or capacity. That is, the cost varies as some power of the change in size or capacity. Okay, now solving for the unknown cost of item A at time t here, you have this formula, no? By simply transposing this known cost of item B at time t. Take note, same time, no? The same point in time. Okay, now where x is the power sizing exponent or cost capacity factor, and where the cost of both items A and B must be at the same point in time, I mentioned a while ago, and where the size or capacity of both A and B must be in the same physical units. Okay, note however that if the known cost of B, of item B, is not at the same point in time as with the unknown cost of item A, the unknown cost of B, which is at the same point in time as with the unknown cost of A, must first be determined using the index method formula, and then multiply this determined cost of B to the power of the change in size or capacity as follows. Okay, so first, this is the formula, no? Where the known cost of B is not at the same point in time as with the unknown cost of A, no? Okay, not at the same point in time. So the instruction is to determine first the unknown cost of B having the same point in time. Okay, determine the unknown cost of B which has the same point in time, no, as with the unknown cost of A. Okay, and using the index method formula. This is the index method formula to find this term. Okay, so this is equal to this known cost of B at time previous time, no, different time as with the unknown cost of A, times the cost index at time t, and the cost index at time this time, no, previous time, and just carry this over here, no. So this is the formula, no. If the known cost of B has a different, or is not at the same point in time as the unknown cost of A. Okay, the value of the power sizing exponent or cost capacity factor can be obtained from a number of sources in the industry, such as industry reference books, handbooks, technical journals, etc. The value of the power sizing exponent depends on the type of plant, equipment, or item being estimated. This is a table of some power sizing exponent values. This was taken from the reference book by Blank and Tarkin. Okay, the items or component or system or plant or equipment, the size range, and the power sizing exponents. For the demonstration on how to use this method, look at this example first. Example 1. Okay, using the power sizing method in estimating a total cost. This example was taken from the reference book by Blank and Tarkin, and this is the problem. Okay, the total design and construction cost for a digester to handle a flow rate of 0.5 million gallons per day, or MGD, was $1.7 million in year 2010. The cost index of 131 in year 2010 has been updated to 225 for this year. estimate the cost of digester today for a flow rate of 2 mgd. Okay, solution. Okay, this is a digester, no? We have to find the total design cost of a digester. Now, from the table of some power sizing exponent values here, you can see that a digester of this size range 0.2 to 40 mgd has this power sizing exponent of 0.14. Okay, so 0.14, no? Since the known cost of $1.7 million of the digester is a cost incurred in year 2010 and thus is not at the same point in time as with the unknown cost of the digester today, the unknown cost of the digester today must first be determined using the index method formula and then multiplied to the power of the change in capacity of the digester as follows. Okay, so known cost and the known cost of digester today. The formula for this is this, using the index method formula. So it is equal to the known cost of digester in 2010 times the cost index today over the cost index in 2010. Okay, and times this. Okay, plugging in the given known values here. Okay, known cost of digester in 2010 is $1.7 million times the cost indexes today and in 2010, and this flow rate today and in 2010 raised to the power of the power sizing exponent 4.14, and you have this estimated cost of digester today. Okay, now another example using the power sizing method in estimating a total cost. This example was taken from the reference book by Sullivan and others. Okay, this is the problem. Suppose that an aircraft manufacturer desires to make a preliminary estimate of the cost of building a 600 megawatt fossil fuel plant for the assembly of its new long-distance aircraft. It is known that a 200 megawatt plant cost $100 million 20 years ago when the approximate cost index was 400. The cost index now is 1,200. The cost capacity factor for a fossil fuel power plant is 0.79, or this is the power sizing exponent. Okay, solution. Since the known cost of $100 million of the 200 megawatt plant is a cost incurred 20 years ago, okay, and thus is not at the same point in time as with the unknown cost of the 600 megawatt plant today, the unknown cost of the 200 megawatt plant today must first be determined using the index method formula and then multiplied to the power of the change in capacity of the power plant as follows. Okay, so unknown cost of 200 megawatt today, and the formula for this is using the index method formula is this. Okay, and then plugging in the given known values. Known cost of 200 megawatt plant 20 years ago is $100 million. Cost index today is 1,200. Cost index today, so on. Okay, and you have this estimated cost of building 600 megawatt plant today. Another example using the power sizing method in estimating a total cost. This example was taken from the reference book by Noonan and others. Okay, this is the problem. A project analyst was tasked to estimate the cost today of a 2,500 square heat exchanger or HE for the new plant being analyzed. She has the following data. Okay. First, her company paid $50,000 for a 1,000 square feet heat exchanger 5 years ago. Another data, heat exchangers within this range of capacity have a power sizing exponent of 0.55. Another data, 5 years ago, the heat exchanger cost index was 1,306 and it is 1,487 today. Now, solution. Since the known cost of $50,000 of the 1,000 square feet heat exchanger is a cost incurred 5 years ago, and thus is not at the same point in time as with the unknown cost of the 2,500 square feet heat exchanger today, the unknown cost of the 1,000 square feet heat exchanger today must first be determined using the index method formula and then multiplied to the power of the change in size of the heat exchanger as follows. Okay, the formula in finding the unknown cost of 2,500 square feet heat exchanger today. Okay, since this is unknown here for the 1,000 square feet heat exchanger today, we use the index method formula to find it, to make it known, okay, using this formula. Okay, and then plugging in the given known values in these terms here, and you have this estimated cost of the 2,500 square feet heat exchanger today. Okay, that's all. Have a nice day, my dear students. God bless us all.